Hello everyone, in today's video we are going to see the continuation of DynamoDB. I'll be discussing more on the demo part. We'll be seeing how you can query and insert values into a DynamoDB table. To do that, I'm going to click on the Create Table button. Now this table is going to be used to host music for a top 40 chart. So we won't require any complex queries on the table, and we also won't require any other relationship to be represented. We're going to give our table a table name. A table name will be music. So let me type the table name, and the partition key will be artist. Alright. Now before I move on, remember the partition key is a mandatory field, and we use this partition key to uniquely identify an item. If we just define the partition key to be artist, it could not always be unique, as artist it may have many songs, right? So because we must be able to uniquely identify items, what I'm going to do is I'm going to give an additional key called a sort key. So this sort key is an optional key, but we will be using an additional combination, and it's kind of a composite key, right? So meaning that this artist plus the song title will uniquely identify an item. So for that, let me click on this checkbox, add sort key, and then let me type the sort key value. So let me give song title. Now, if you look at our partition key, it is combination of artist and a sort key song title. We are also going to leave the types for both of these keys to be strings. Now we are going to scroll down and leave the rest of the table defaults. This will determine our throughput allocated and define a read capacity units and write capacity units. Now we can finish creating our table by scrolling down and clicking create. Now our table will be ready for us to begin using with. We can click on the different tabs here to view the different aspects of our table, like we have items, metrics, alarms, capacity, and many more. We're going to learn about these different aspects as time goes on, but for now, let's click on the items tab. So in items tab, we can see here that we don't have any items in the table, but if we did, we could be able to see or view those items here. We will be using the put item API call on the command line to populate our table. So throughout this video, we will be using a AWS service called Cloud9, which will act as an ID to execute our SQL queries. So in other tab, I have opened AWS Cloud9. As you can see here, this is an IDE environment. You will be using Cloud9 IDE in the exercise. The IDE contains a terminal. This terminal will allow me to use the command line to invoke the API calls, which you can see below the screen. And here we will be execute most of our queries. Now before we start any further to execute our queries in Cloud9, let me also reiterate the partition key concept here. So let me open my notepad. Okay, so say for example, you're giving a primary key. In our case, the primary key is, let me go back. So the primary key which we have created is artist and song title. So artist and song title combined defines a partition key, and as you know, partition key is basically used to decide where our data is going to be stored. So if we have more than one servers, the partition key is going to decide on which server our data is going to reside. So how does DynamoDB calculate based on the partition key? It basically uses a hashing algorithm. So let's assume you have a hashing function. Let me increase the font size so that it will be easier for you to view it. All right. Let us see, you have a hash function, and in that hash function you're passing the primary key, and this will give you a number. Generally this number is used as a modulo of number of machines. If in our case we have a 3 machines cluster, then the mod of number of machines, so which will be 3 here, plus 1, and the result is where the DynamoDB will decide where our data will be stored. So just to give you a fair example, let's say our primary key is 1, so this will go into the hashing function, and the value hash of 1 will be alphanumeric character. It could be A, B, C, D, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Now this will be converted into a number which will further be 1, 2, 3, 4, 5, 6, and this number will be mod to the number of machines. So here 1, 2, 3, 4, 5, 6 mod of, say for example we have 3 machines, so mod of 3, this will give 2. So mod means the remainder, right? So the remainder of, let's assume the remainder is 2, so 2 plus 1 is 3. So this primary key or this item will go into the third server of our DynamoDB. So this is how the primary key or partitioning works, and based on this hashing algorithm the DynamoDB will decide where, in which server our item has to reside. Okay, so now let us go back to our Cloud9 IDE and let us try to run a very simple query. So currently I'm just going to execute a query to list the number of tables. Okay, so it goes like AWS so AWS followed by DynamoDB followed by list hyphen tables. Now let me click enter. So as you can see, it has listed down the tables which we have created. Right now we have just created one table called music, and it is listed down the table name which is music, which we have just created in our AWS console. Let me close this. So we have created this table. There's only one table which we have created, and it is able to list down. If there are more than one tables, it will give a list of all those tables which we have just created. Now all the queries which I'll be using in this video, I will be pushing that in Git, and I'll be sharing the link in the description section so that you can download the scripts and you can practice it by yourself. You can see that the music table is listed here. So next thing we're going to do is I'll try to add few items into the table. For that, I have 3 JSON files loaded into my Cloud9 environment. I'm going to use these JSON files to load the data for each item into DynamoDB to avoid trying to type out the JSON file. So the first JSON file which I'll be opening is the song1.json. So in this song1.json, you can see that we have the first song we want to add to the table. This item has few different attributes. We have artist, which is Sonu Nigam. We have song title, which is Dil Deewana. The album title is also Dil Deewana, and the genre is rock. And the first attribute, which is S, which it denotes the data type. So the data type of all these attributes is string. Using this JSON file, I'm going to run the commands to put items into the table. So the first command we're going to run to put an item into the table is, let me go back to my, so it is AWS space DynamoDB followed by put hyphen item So the table name which we are giving is music, and I'm calling the API put hyphen item, and then I have to refer the JSON file which I'll be using to insert. So it goes hyphen hyphen item followed by song1.json. Let me click enter now. So I hit enter, and now that should have been added to the table. We're going to do the same thing for the next two songs as well. So let's go ahead and check out the JSON as well. So for the song 2, I have artist as Arijit Singh, song title, and album title. So let me go ahead and add this. I'll just go back to the terminal and I'll just edit the JSON file name alone. We will do this for the song 3. So I'll just go back and edit the command and refer song3.json. Let's go back to the DynamoDB console to check it out there first. I'm going to click on my other tab which has the DynamoDB dashboard. And I click on the items tab, we are already there in the items tab. Let me click on refresh. And here you can see all the three items which we just used to enter using the CLI command. So for example, we have Arijit Singh with 3 attributes. We have David Bowie with song title and album title and release date, and Sonu Nigam with again uh, 3 different attributes: a song title, album title, and genre. If you can just see, the schema is completely different for each of these items. So that is the speciality of using a NoSQL database. You can add a new attribute at runtime and your DB will not complain. So each item can have its own different schema. Now, mostly in a production environment, you won't be having AWS console to go and view the data. So you will be you'll be querying the items using a software or an SDK, using a Java program or a Python or any programming language for that matter. So we're going to use a command line to query the table. So let me go back to the Cloud9 and we will go from there. So I'm going to come back to the Cloud9 here. Let me go back to the another tab. And now what I'm going to do is I'm going to query the DynamoDB starting off with the same command. So the command will look like AWS space DynamoDB followed by query. And in the query, we have to give the table name, which table name we are querying. So hyphen hyphen table name. The table name which we have given is music. That's a spelling mistake. Music. And the next value we are going to give is, we have to query this table, so we need to give some kind of a query parameter to query it. So from here, we are going to give something called key condition expression. A key condition expression is what allows us to search the table for items that have a certain partition and a sort key values that match our input. In our case, we are first going to search on just the artist name alone, and then we will query based on artist and song title together. So for this purpose, again, I'll be using a JSON file to avoid writing. So the JSON directly on the command line. So let's take a look at the JSON file we have in our Cloud9, and you can see us describing data we want to pass in our query. So the JSON file we're going to open is values1.json. So in values1.json, we are passing the artist name, which we are using to query. So based on this, let me continue with my query. So we have given the table name so far, and next thing we are going to give is hyphen hyphen key hyphen condition hyphen expression. key hyphen condition. So this is how the query looks like. So we have key condition expression, then we will provide an expression that describes what key we are querying against. For us, that is going to be artist, and then we will say artist equal to colon v1. This colon v1 is representing a variable that we will pass values into. So v1 is essentially just a placeholder that we will pass in a value to. The next piece that we have to provide is passing in those expression attribute values or the actual input to the query. So I'm going to pass expression attribute values, that is nothing but our JSON file which we just saw, which is values1.json. So before I hit enter, let us quickly go back to our values1.json. So this v1 is the placeholder I was talking about, and we are giving the same placeholder v1, and this is nothing but the artist. So we are going to say this is like select star from table where artist is equal to Sonu Nigam. So if you just want to compare it with an SQL query. So let me click on enter here, and you can see it has returned one value. And if I just scroll down, the number of items is 1. It is displaying the album title, basically the different attributes of that particular item: the album title, artist, genre, song title, and number of count is 1, and scan count is 1. So this is the output. Let me enlarge this for you. So for the query which we have just executed, this is the output. And to just verify, let me take you to the AWS console. So we have queried basically the item whose artist name is Sonu Nigam, and there is only one item currently present in the table, and that's what is being returned to us. So this worked out pretty nice to us. So what we're going to do next is query on both the partition key and the sort key. So if we look at the other JSON file provided, we can see the values we're providing for artist and song title for our next query. Let me quickly show you that. This is another JSON file which I'll be querying. So here we have the artist name. So currently we don't have, so let me give the artist name as Arijit Singh. And the song title would be O Meri Lag Gaye. I hope Arjit Singh fans are not angry. This is just for the demo. Let me save this file. So let's go ahead and execute this. So here we can see the first variable that we're passing, and the second value that we're going to pass is the song title. So let's go ahead and run the command. So for this query, we're going to start it very similarly to the last one. So we are going to use the last command and backspace up to the part where we provide the key condition expression. So in the key condition expression, we provided just the artist, which was the partition key, but this time we also want to provide values for the song title, which is a sort key. This is going to allow us to narrow down our results to one item. So we are going to here say and song title equal to colon v2. So this is a query where v2 is our placeholder for the input that we will pass in our expression attribute values. So now let's go ahead and provide that expression attribute values through the value2.json. Before running, let me again go to the value2.json and show you. We have v1, v2, which are the placeholders, and we are providing those placeholders v1, which is the artist, and v2, which is the song title. So let me go ahead and click enter. So now it has narrowed down the results. It has given me one item with album title, artist, and song title. So this is how you narrow down the results based on both the partition key and the sort key. As you can see, we can query on either just the partition or the partition and the sort key together. As our table design sits right now, we cannot query on any other attribute like release date or maybe album title. For that, we need to introduce a concept called indexes, secondary indexes. We will see that later. Right now, we will try to query based on the other attribute values. Now, before we execute some other read-write queries, let me show you how to delete a particular item through our delete API. So for that, let me copy the delete query for you in the Cloud9. So I'm going to delete a particular item whose artist name is Arijit Singh and the song title is what you see on the screen. So for that, let me go back to the terminal and copy this query. So it goes like AWS DynamoDB delete hyphen item, which is the API name, followed by the table name, and then we are giving the name of the table, and hyphen hyphen key. I'm passing a JSON file, and if I open the JSON file, this is how it looks. I'm giving artist and song title. Now before I execute, let me show the number of items. Let me refresh. So there are 3 items and we're trying to delete this particular item. Let me go back to my IDE and execute this particular query. Now let us go back to our console and see how many items do we have now. We should be able to see only 2 items. So that works fine. So we were able to delete a particular item successfully. Now let us try to scan the table and see whether how many records have been deleted. So it goes like AWS DynamoDB followed by scan and the same table name. By now you must be knowing how to give the table name, hyphen hyphen table hyphen name, and then give our table name, which is music, and this should return us, oops, that's some spelling mistake, some very silly spelling mistake. It's dynamo. All right, so if you look at the output, it is giving us 2 items which are pending in our table music. So it is beautifully displaying both the items with each of its attributes here. So if I just revisit the query which I just executed, I'm using AWS DynamoDB followed by scan. So there are 2 ways where you can read the data from your DynamoDB table. The first way is scan and the second way is query. We have seen this in our previous video where we have queried our table using AWS console. Just to reiterate, a scan will basically scan each and every item from your DynamoDB table, whereas the query will query based on the partition key. So when you query, you have to give the partition key and it will go to the corresponding server where the particular item resides, and it will query that particular server and give back the result. So your query is much more efficient and faster if you query based on the partition key, whereas scan will not be that efficient and the performance will not be as faster as compared to querying using the partition key. So if you have to explain it in a better way, scan is more like a select star from table name, and a query is more like you're adding a where condition to it, because doing a scan has to pull back all the items in the table. It could be very expensive. Once a scan brings back all the items in the table, then you can do a filter, you can add some optional filter, and then you can get items based on the specific attribute values that you want. So we have just ran through a basic scan operation. The next thing what we will be doing is we'll try to query based on certain filter parameters. So for that, let me edit this particular query. So guys, this is the query which I'll be executing now. It's AWS Dynamo query followed by the table name, and then what I'm basically trying to do is I'm planning to query based on the artist name and the release date. So artist name is part of our partition key, but our release date is not part of our partition key, right? So for that, I have to add a filter expression to first retrieve the values based on the artist, and then apply a filter on top of it based on an attribute called release date. And for that, I'm also this like how we did for the previous queries. Even in this query, I'll be passing a JSON file called filter values1.json. Let me open filter values1.json for you. Here, this is the artist name and the release date. Do we have this artist of this name? No. So let me first do an insert query. So let me go back. Let me try to insert this particular item. Put item song 3. Let me put song 4. And we have another JSON called song5.json. Okay, so there's some problem in song 5. Let me quickly go back and check. Song 3, song 4, song 5. All right. So let me edit the filter JSON in that case. So filter values1.json. So I'll be changing the artist name to David Bowie. And do we have a release date for him? It's 1998. So let me save this file and go back to my terminal. And let me reiterate what I'm trying to do. We are trying to query based on the artist name, and on top of that, we are applying a filter based on the release date. And I'm passing those input parameters using filter values1.json. As usual, we are having two placeholders, v1 and v2. So let me click enter, and here it goes. We are getting the particular item based on the filter values. To make this example a better one, let me add one more item with a different release date of the same artist. So we have uh, which artist is it? It's David Bowie. So where do we have David Bowie here? Let me add another item with a different release date, and this is song3.json. So now we have two items. No, we don't. So the value got overridden because we have given the same song title. So ideally the song title has to be different. So I'm just giving a different song title, and let me change it to 1998. So basically it should create two items for the artist David Bowie. Yeah, so we have two items of the artist David Bowie. The song title is different and the release date is different. Now it makes more sense if I execute the query for you. So filter based on artist and the release date. So this should only return one item because we only have one item with a combination of artist name and release date as 1998, right? So that's the reason it is giving us only one item, and it is filtering out the another item with release date 1999. So first it will fetch all the items whose artist name is David Bowie, and on top of that, so initially it will get two items. On top of that, it will apply a filter condition based on the release date, and it will filter only one item, and it will return back another item for us. So that's the reason you're seeing only one item in this console. So I guess now you have a clear idea on how to read, write, or query your table based on the query APIs which we have just seen. So we have seen different API queries and how you can put, read, query, scan your DynamoDB table. So the next thing we're going to see is how to create a backup, right? So let me clear my screen. Now, in order to create a backup of a table, let me close all of these. So before we create a backup, let us go back to our AWS console and take a look at our music table. So we have a table with 4 items in it. So sounds good. So let me create a backup of a table using our similar API queries. So for that, the query will look like AWS space DynamoDB followed by command called create hyphen backup, and then give the table name. So hyphen hyphen table name, and what's the table name? It's going to be music. And after that, you have to give a name of your backup table. So the command for that is hyphen hyphen backup hyphen name followed by backup table name. Let me give something as music backup. So this query, what it basically going to do is it is going to create a backup of your table. So we are telling him take a backup of table music and rename that as music backup. So let me hit enter now. So as you can see the output, it is giving back the ARN detail of the backup DB, and then the backup status is still creating. So in order to check the particular status of it, so I need to give another command AWS DynamoDB, or let me just hit backspace, and instead of create backup I'm going to execute the command describe backup. Now followed by describe backup I have to give the ARN number, so I will give hyphen hyphen backup hyphen ARN followed by the ARN. Let me copy paste this ARN here and paste it, and let me check the status of it. So if I just scroll down a bit, it's going to give me the table details like backup parent, what is the backup table name, what is the backup size, backup status is available. So basically our backup is now created, and if you look at the key schema, this is same as what we have created in our music table. Artist and song title is our partition key. So to verify this, let me go back to the console and click on backups. As you can see, the backup has been created. Now that our backup is created, let us try to restore this backup. So for that, let me go back to my Cloud9 and go to the query AWS followed by DynamoDB. And after that, you need to give the API restore hyphen table hyphen from hyphen backup. So restore hyphen table hyphen from hyphen backup. Now followed by this, we'll be giving hyphen hyphen target table name. So we will give our target table name as something music restored. And followed by that, you need to give the ARN number of your backup DB. Now let me copy paste the ARN details here. Let me scroll and copy this backup ARN and come down and paste it. So basically what we're trying to do is we have created a backup of our music DB, and based on that backup we are trying to restore it, and we are giving the name of the table as music restored. Let me click enter and let me check the status of it. Let me go up. So as you can see, the it is giving us the attribute definition. This is the partition key. Table name is music restored, and the table status is creating. So let us go back to the AWS console and go to tables. We should see the another table which is not yet ready. It is still creating. Okay, so here you can see the table music restored. It is still restoring. Let us give a couple of seconds for the table to be created, and then we can check if the same number of items is being replicated in our restored table. We can also check this using our queries. So let me click enter and give AWS DynamoDB followed by describe hyphen table and then give the table name. So the table status is still creating. It hasn't created it. Let us wait for a few seconds. The restoring table might take a few more time. So until the table has been restored, let me also talk about some other API queries. So generally in production environment, when you're using Dynamo table, you're going to have huge amount of data in terms of petabytes and terabytes. So when you use to query or scan the data, you cannot have more than 1 MB of value returned from your table, right? So for that, you need to paginate your query. So how will you restrict, say if you want to just retrieve the first 10 items or you want to retrieve the first 20 items, so how would you retrieve, how could you paginate or restrict the amount of items do you want to uh, retrieve from your table? So for that, we have a command called hyphen hyphen max hyphen items. Let me quickly show you that. So AWS Dynamo followed by scan. So we are scanning the table and we need to provide the table name, and the table name will be music, and then the command we're going to use is max item hyphen hyphen max hyphen item, and currently there are 6 items in music, so let me retrieve only the 2 items and hit enter. So this will retrieve me the first 2 values of our table. So there are totally 4 items, and it scanned all the 4 and it retrieved the first 2 values. So this is how you restrict on how much data you could retrieve from your DynamoDB. So let us check on items, and you can see 4 items here, and what did it return us? It returned us David Bowie and Heroes and My Life. So it has returned these two. It has returned the David Bowie, Heroes and My Life. So it has returned only the 2 items out of 4. So far so good. So let us check if our restoration is complete. It's going to take a long time. So the next thing what we're going to see is how to have a bulk write operation. If you want to do a bulk insert operation, so far what we have done is we have just inserted using a single item where we have our songs1.json, and songs1.json we have given a particular item is in a JSON format and we have inserted one item at a time. But there could be a scenario where you want to do a bulk write operation. So for that, I'm using another JSON file called bulk write. And if I just scroll up, you can see that I'm trying to insert more than one items in one go. So instead of just inserting one by one, I'm using a bulk write operation. So how can I do that using an API query? So for that, let me write the query AWS DynamoDB followed by the command batch -write -item. And then you need to give the request item files. So that will be followed by hyphen 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 request hyphen items and followed by the JSON file name. In our case, it is batch write.json. So I will be giving the file name after this. So before I execute this, what we're going to do is first check our console and see how many values. We have 4 items currently, and let me execute this command. I think in this command we have a couple of items. We have 1 put request, 2, 3, and then 4. I'm trying to insert 4 values into it, and here I'm giving the table name. So the JSON has to be constructed in this way. This should be an array and the name of the array should be the table name. So in our case, the table name is music, and within the music I'm having multiple put requests. Inside each put request there will be an item, and inside that item I will be specifying the attributes of that particular item. So the JSON structure will be an array whose name is the table name, and inside that array you have multiple put requests, and inside each put request you have another JSON structure called item, and inside item you specify the attribute names which you want to be included in that particular item. So let me go and hit enter. So as you can see, it has returned an unprocessed items are null. So basically if any one of the item is not able to process, it will be included in this array. So when could that be a scenario? That could be a scenario when out of your 4 put request, in any one put request the JSON format is not properly structured, or that is some typo error. In that case, it will skip that particular item and it will start inserting the another items, and the items which it is not able to process will be returned in this unprocessed item array. In our case, all the items which we gave in our batch write.json got processed. So let me cross check it. Let me go back to the music and click on refresh. So we should be able to see 8 items. So all the items which you just gave in our batch write got inserted. So that's a good news for us. So our batch write query was successfully executed. So let me go back to a table and see if our restoration is complete. Yes, the restoration is now complete. Let me click and let me go to items, and all the 4 queries are being restored successfully. So these 4 items are before we have actually restored our table before we executed our batch write. So all the new items will not be included here. So these are our old table. So all the 4 items which were included in our music table before the batch write can be seen here in our music restored. So guys, I hope you liked today's video. We have discussed about various queries and APIs to put and read and query using scan and query method, and then we have seen how to use a batch write. We have seen how to describe a table. We have seen how to use pagination to restrict the number of items while querying your table. So we have almost seen most of the things. So if you want me to discuss some more items in DynamoDB, please comment down in the comment tab, and don't forget to subscribe my channel. Thank you so much, and see you again in some other interesting video. Goodbye.